We're going to look now at a chi-square test of association between two categorical variables. So in this case, one of the two categorical variables is highest degree held. So a junior college degree, a bachelor's degree, or a graduate degree. And we're assuming highest degree so that if somebody has any two of these three or all three, we would only count them under graduate. Or we would only count them under the highest. And over here, this is views about astrology, the other variable, astrology. So first, let's just fill in some totals here so that we can do some calculations. It looks like our totals, the number of junior college degree holders in our sample is 75. Bachelor's degree holders 184, graduate degree holders 98, and the number of those who think astrology is scientific of those surveyed is 237. Of those who think astrology is not scientific, and of those who think it's scientific, 120, for a table total of 357. Remember that to get the table total, you either add up the row totals or you add up the column totals. You don't add them both to each other. Now we can calculate a few sample proportions from this table. The proportion of junior college degree holders who think astrology is scientific. Remember that to calculate that, our universe is junior college degree holders, and we need to make sure that our computations come only from this column. We would not take our denominator from the, like for example, all of those who think astrology is scientific. That number is not going to be relevant. Everything comes from the universe of degree holders. So my P1 hat is 31 out of 75, which comes out to be about 0.413. My proportion of bachelor's degree holders who think astrology is scientific, this is going to come strictly from the bachelor's column. So P2 hat is 62 out of 184, which at least in our sample does seem to be smaller at 0.337. We don't know yet whether this difference is statistically significant, but at least it's smaller in our sample. And then finally we've got P3 hat, same for graduate degree holders. This is going to be 27 out of 98, which is 0.276. All right, so it does look like there might be some difference here, and it is worth investigating this question of whether the degree held is associated with views about whether or not astrology is scientific. One thing that might occur to a person to do is to compare these pairwise. And this problem of multiple tests we've brought up a couple of times now, but we'll really illustrate it well with this example. If I were to come up with confidence intervals pairwise for these differences, so this is the difference between junior college degree holders and bachelor's degree holders who think astrology is scientific. Junior college and graduate, bachelor and graduate. Looking at each of these and thinking about the two-sided alternative hypothesis that they are not equal to each other, I would say this first confidence interval starts at a negative value, it ends at a positive value, and therefore it includes 0, and therefore we would fail to reject the null hypothesis. So we would fail to reject the null hypothesis that P1 is equal to P2. This next one, we start at a negative value and we end at a negative value, which means we don't include 0. We would reject the null hypothesis that P1 is equal to P3. And in this third, we're back to negative to positive this does include 0. And so we're back to failed to reject. The idea that P2 is equal to P3. So if we were to look at these pairwise, we might be tempted to say that we have statistical significance on one of them. But remember, the problem of multiple tests says we're not allowed to do that. Unless I knew a priori that comparing junior college to graduate was what I wanted to do, then I'm not allowed to look at all 3 of these and just pick out the one that gives me statistical significance. I might have guessed a priori that that one would be the strongest because those 2 degrees are the farthest apart, but I'm not allowed to go back and second guess that decision now, right? So the problem of multiple comparisons really is that this isn't valid, right? This is not valid. We really need one test that is going to allow us to compare all of these proportions. We need one test for the whole table. Because we're much more likely to get something statistically significant just by luck if we do lots of comparisons.